2021, grade 12, AMC 12B, fall questions 21 through 25. Problem 21. For real numbers, let p at x equal to 1 plus cos x plus I sine x minus cos 2x minus I sine 2x plus cos 3x plus I sine 3x, where I is the square root of negative 1. For how many values of x between 0 and 2 pi does p at x equal 0? Well, the key to this question is to make a substitution, and that substitution is let something equal to cos of x plus I sine of x. And when you do that, this expression, this entire expression, essentially boils down to just 1, and then this part, of course, is just a, and then this part becomes a squared, but remember, there's a negative, so it's negative a squared, and then this part is a cubed. So that's the magic, I guess, substitution. Now it boils down to figuring out the roots of this guy. Well, I'm not going to go through, trying to figure out the roots of a third-degree polynomial, so we can estimate. Let's plug in some values. If I plug in negative 1 into this, I get negative 2. If I plug in 0, I get 1. So obviously the root is somewhere between negative 1 and 0. It's negative 2, say, there. This is negative 2. And then when it's 0, it's 1. It's up here somewhere. So obviously this graph, if you were to graph it, I have no idea what this graph looks like, but it's going to cross the x-axis somewhere between negative 1 and 0. So the root is somewhere between negative 1 and 0. Correct? So they're asking how many values of x between this range is that 0. Well, since the root is between negative 1 and 0, the root cannot be between 0 and 2 pi. So the answer here is none. There are no roots between 0 and 2 pi that would make that equation equal to 0. So the answer for this is A. Problem 22. Right triangle ABC has side lengths BC is 6, AC is 8, and AB is 10. A circle centered at O is tangent to BC at B and passes through A. A circle centered at P is tangent to AC at A and passes through B. What is OP? Okay, so first we have to draw this diagram, so let me see if I can do that. Okay, so it's not a work of art, but hopefully it should be sufficient to explain what's going on. So first let's label the ABC. So here's A, here's B, and here's C. So when you draw that triangle like that, basically you got that triangle, right triangle ABC, right? And they're saying that BC is 6, so this point is 0, 6, and they're saying that AC is 8, so this is 8, 0, like that. And of course C I put at the origin on this graph. Okay, so far so good. So then you got two circles. The one circle is centered at O, and it passes through B and A, and it's tangent at B. Okay, so we can put a little right angle because that's what it means when it's tangent. And then the other circle is, this is O right here, this red dot, and this is P, this green dot. Okay, so then the other circle is centered at P and tangent to AC. So we'll put the little right angle there and passes through B. So both of them actually go through A and B, it looks like. Okay, so what do we do? All right, let's see here. Well, the first thing is I want to draw this sort of this imaginary line from P all the way down to A. So like that. And then it's tangent, so that works out really nicely. And then I'm going to draw one more line from P through O like this to make it land there. And I think the way I draw that line, I'm going to do it in a way so that it's perpendicular. And I think that should be it. Now, the coordinates of O, because it's on this line here, it's 6 for the y coordinate, but for the x coordinate I don't know, so I'll just put A 6 for the coordinates of O. And for coordinates of P, the x coordinate is 8 because it's on that line that goes all the way down to A. But then the y coordinate I don't know, so I'll call B. Okay. So what is our goal here? To figure out OP. All right, so it looks like we're going to have to figure out the distance formula. Okay, well, the circle formulas, you guys know how to figure out the formula of a circle. Circle formulas. The first circle, the circle at O, looks like it's x minus a all squared plus y minus 6 all squared is equal to a squared. Right, because a is the radius. And the next circle, the circle centered at P, that is x minus 8 squared plus y minus 6, or y minus b, sorry, squared is equal to b squared. Okay, well, both of these, the good news is that we have a point on both of them. For example, on the circle that's centered at O, we have the point 8, 0. The circle centered at O passes through A. So we can substitute 8, 0 into that. So we can put 8 minus A all squared plus 0 minus 6 all squared is equal to A squared. And the circle that passes through P, or centered at P, I should say, that one passes through B, so we can put that point 0, 6 into that. So we have, therefore, 0 minus 8 all squared plus 6 minus B all squared is equal to B squared. And there you go. And I think that should be sufficient to figure out A and B. Yeah. Because this just has one variable, and this also has one variable. Okay, so when you do solve for those, I'll let you solve for them. They're fairly straightforward. You get A equal to 25 over 4, and B equal to 25 over 3. So now we have the points, O and P. O, therefore, is 25 over 4, 4 and 6, and P is 8 and 25 over 3. So there you go. Now all you have to do is use the distance formula to figure out the distance from O to P. So the distance formula, you guys know that. So O to P, the distance would be 25 over 4 minus 8 all squared plus 6 minus 25 over 3 all squared. And of course you take the square root of that. And when you crunch out these numbers, you get 35 over 12. So therefore, the answer to this question is C. Problem 23. What is the average number of pairs of consecutive integers in a randomly selected subset of 5 distinct integers chosen from the set 1, 2, all the way to 30? For example, 1, 17, 18, 19, 30 has 2 pairs of consecutive integers. So do you guys understand this question? So they've given you an example. So what they do is they take this subset, right? Or this, whatever, this set. And they're going to choose 5 integers from it. So for example, they chose 5 at random. And from that subset, they're saying, how many pairs of consecutive integers? Well, in that case, we have 17, 18. That's one pair. We have 18, 19. That's another pair of consecutive integers. So in this case, there's 2 pairs. What they're saying is that if you kept repeating this process, what is the average number of pairs of consecutive integers that you would get? On average, how many? All right, so we got to think about this. There's 30 numbers, right, in this big set. And you need to choose 2 to get a pair. So from 30 choose 2. That's how many number of pairs you would get. Now, they're not necessarily consecutive, just pairs. It could be the number 2 and number 16, or number 12 and number 18, but just the number of pairs. Now, in that set, there's 29 pairs of consecutive integers, right? And those pairs you can figure out are pretty straightforward, like 1, 2, that's one pair. 2, 3, that's one pair of consecutive integers. 3, 4, and so on, right? All the way down to the last one, which would be 29 and 30. Got it? So the probability that a pair is consecutive is 29, which is the specific condition, over the total, which is 30, choose 2. So this is, I guess, our probability. But it's not that simple, because we have to also multiply it by something. For this, we have to take this and multiply it by something. And I say, what is it that we have to multiply by? We have to take into consideration that we are choosing 5 numbers, right? From, like they say, we have to choose 5 from this set. And from those 5, we have to choose a pair. So from 5, you have to choose 2. From 5 numbers, you have to choose 2 numbers. And those basically represent the pair of consecutive integers. So that's what we have to multiply this guy by. That would make the question complete. So in total, it becomes 5, choose 2, times 29 over 30, choose 2. Like that. Got it? And let's see, it shouldn't be too hard. 5 factorial, 3 factorial, 2 factorial. That's just a 29. And this is 30 factorial, 28 factorial, 2 factorial. So let's see here. This becomes 5 times 4 over 2. This becomes 29. And then let's invert and multiply. So this will be 2 over 30 times 29, right? Yeah. So these 2's cancel. This 29 cancels. So you just get 20 over 30, which is 2 over 3. And therefore, the answer is A for number 23. Problem number 24. Triangle ABC has side lengths AB is 11, BC is 24, and C is 20. The bisector of angle BAC intersects BC in point D and intersects the circumcircle of ABC in point E, which is not equal to A. The circumcircle of triangle BED intersects the line AB in points B, and F does not equal B. What is CF? Okay, so let's draw this diagram first. Okay, so I have drawn the triangle, and that triangle is ABC, and then I've drawn a circle around it, so representing the circumcircle ABC. And let's start with the question. So we can label this, right? It's 11. AB is 11, BC is 24, and CA is 20. Okay, great. And then the bisector of angle BAC, so a line that bisects that, so like that, I guess. And therefore, this is theta, and this is theta, because it cut that in half. Intersects BC at D, so this is D right here, and intersects the circumcircle at E, so this is E right here. Got it? And then the circumcircle of BED, so, we got another circle in here. BED, so a circle that passes through BED, so something like this. That intersects the line AB at F, I believe, right? At F. Okay, so Let's see here. So F is, I guess, this guy right here, somewhere in here. And this is F here. That's F right there. Okay. Not a perfect circle, but that's okay. You guys understand. So they want you to figure out the length from C to F. So running out of C to F. So that distance. All right. So here we go. All right. We're going to label this angle in here. I will label that full angle. I will label, I guess, alpha. This angle right there. Okay. And then therefore this angle down here would be 90 minus alpha. I'll just write it out here like that. Okay, and then I'm going to join one more, this B to E like that. I'll join that. And then sorry, that would not be 90 minus alpha. That would only be true if it was a right angle, so I can't put that 90 minus alpha assumption. And let me draw these triangles out here to avoid making this diagram messy, because it's already getting kind of messy. So let me draw that first triangle, ADC, out here. So that's theta, that's alpha, and this angle here would be 180 minus theta minus alpha. And then let me draw another one, that ABE triangle. ABE. And that's, let's see here, theta. That's theta. And this angle here is alpha. Now you say, well, why is it alpha? Because if you look at the points A and B, the points A and B subtend to result in alpha, right? Because you're making alpha when you drop a line from A to C and then from B to C, that makes alpha. But if you take A and B and drop a line to E, therefore that's also going to be alpha. So that is why that's alpha. That's a fundamental property. Angles subtended by points A and B. So alpha is angle formed by subtending from points A and B. And therefore this angle in here, same thing, has got to be 180 minus theta minus alpha. So that, in a very painful way, I wanted to explain that makes those two triangles similar. So ADC is similar to triangle ABE. Got it? All right. So now we can actually move forward with the question. We needed to establish that. So by similar triangles, that means AC over AD is equal to AE over AB. Got it? And therefore we can cross multiply and get AB times AC is equal to AD times AE. Okay? So hopefully there's no confusion there. Now we have a lesser known theorem. It's called the power of point theorem. Some of you may know this, some of you won't know about it, but that's okay. I will explain it. So it involves a circle. And let's say you have a line that crosses through like that. And let's label these points A, B, C, D, and E. The power of point theorem states that in such a diagram, CB times CA is equivalent to CD times CE. Okay, so we are going to apply that on our diagram. On our diagram, when you apply the power of point theorem, you will get that AB times AF is equal to AD times AE. Okay? Applied to the red circle, in case you're wondering which circle did I apply to. AB times AF is equivalent to AE times AD. Got it? So this is my equation 1, and this is my equation 2. And when you combine them, you'll see that since that equals this and that equals this is the same as this. So that means the other two sides must be the same. So that means AB times AC must be equal to AB times AF. And lo and behold, you get that A and AC is equal to AF. And AC, they told you, is 20 in the question. And there you go. That is all that hard work to get that AC is equal to, AF is equal to 20. AC equal to 20, we already know that, but we had to conclude that AF is equal to 20. Got it? Not AB, AF. And that kind of makes me a little confused here, because the diagram, obviously the way I drew it, AF's got to be shorter than 11, so how can it be 20? That makes me look back to that sentence there, and makes me think that the line AB, so I think what they're doing is they're extending this line AB, and the way I drew the circle is probably wrong, that it's more like a scenario like this, where like that. See what I mean? Where this point is F right here. That's the only way it would make sense that AF could be 20. Okay. That's okay. Well, at least I caught it at the end, in the sense that I'm trying to figure out how this question would work. Yeah, they would have to intersect the line AB out. The line is extended. Okay. All right. Well, regardless, that's how this question is proceeding. Okay, so now what you do is you lose you lose your mind. You use the law of cosines on triangle CAB. So I wish I can put it in here. I can just turn it over here. So CAB, that triangle, use the law of cosines. So the law of cosines on CAB would give me BC squared is equal to AB squared plus AC squared minus 2AB AC times the cos of 2 theta is that angle. Right? Yeah. Okay, so BC, I think we have all these numbers. 24 squared, 11 squared, 20 squared, minus 20 times 11 times 20 cos 2 theta. And then when you crunch out these numbers, you get cos of 2 theta is equal to negative 1 over 8, right, after you make all the calculations. And then finally, you do the law of cosines again, but this time on one final triangle, that's CAF. CAF, that is going to help us figure out what is CF. So that means CF squared is equal to AF squared plus AC squared minus 2 AF times AC cos, this time again 2 theta. So CF is what we are trying to figure out. AF we had concluded was 20, and we had to redraw the diagram a little bit because it didn't make sense. And then AC is 20 minus 20 times 20 times 20, and then negative 1 over 8. And there you go. You got all the numbers there. So when you crunch out these numbers, you finally get that CF is equal to 30, and that is the answer to this question, and therefore 24 is C. Problem number 25. For n, a positive integer, let r at n be the sum of the remainders when n is divided by 2, 3, 4, 5, 6, 7, 8, and 9, and 10. For example, r15 would be 1 plus 0 plus 3 plus 0 plus 3 plus 1 plus 7 plus 6 plus 5, which is 26. How many two-digit positive integers satisfy r at n is equal to r at n plus 1? Okay, so you have to figure out a value for n that is 2 digits, so it's between 10 and 99 inclusive. That would satisfy this condition based on this definition. And you will arrive at this using mod, because it's always talking about remainders. So for example, after some trial and error, you get 13, and let me explain. So first what you do is you take 13 and divide it by each of these. So 13 divided by 2, the remainder is 1. I'll just write what we divided by. And then you add to it 13 divided by 3, the remainder is 2. No, it's 1, sorry. Then 13 divided by 4, the remainder is 1. 13 divided by 5, the remainder is 3. 13 divided by 6, the remainder is 1. 13 divided by 7, the remainder is 6. 13 divided by 8, the remainder is 5. 13 divided by 9, the remainder is 4. And finally, 13 divided by 10, the remainder is 3. And when you add all these guys up, it's 25. And then this guy, Rn plus 1, would be R of 13 plus 1, which is basically the R of 14. And the same kind of story, you would take the remainders when divided by 2, 3, all the way up to 10. And those remainders are 0, plus 2, plus 2, plus 4, plus 2, plus 0, plus 6, plus 5, plus 4. And that is also 25. So there's an example of a situation where R of n is equal to the R of n plus 1, where n is equal to 13. Got it? So this is a question that obviously involves trial and error, but there's no way you're going to go through every single number from 10 to 99 on a math contest. That will take forever. So you've got to figure out a pattern using mod and come to a conclusion. And the other one that works is 97. 97 would be equal to 27. And then if you do R of 97 plus 1, which is 98, you would also get 27. So that's the other one. So 13 and 97 are the two values that solve this equation. So therefore there's only two solutions, and therefore the answer is C.